5.2, instead of us just talking about polygons, in 5.1 we talked about three-sided shape, four-sided shape, five-sided shapes, pentagons, hexagons, octagons, things like that. We're going to now narrow things down, and the rest of this unit is going to be on four-sided shapes. The first four-sided shape that we're going to talk about specifically is something called a parallelogram. The definition of a parallelogram is a four-sided shape that has both pairs of opposite sides are parallel, meaning these sides are parallel and these sides are parallel. One of the things that I like to point out is a rectangle is a parallelogram. If you think of a rectangle has both sides that are opposite each other. They are parallel to each other. It's a parallelogram. A square is a parallelogram because a square has both pairs of opposite sides are parallel to each other. There will be more specifics on those things in later sections, but right now a parallelogram is a quadrilateral with both pairs of opposite sides parallel. These four properties are true when they're a parallelogram. On your worksheet today, the one that you have in front of you, there are several problems, and they're going to ask you for what property are you using. These are the four properties that you can use to solve problems with parallelograms. The first property, if the opposite sides are congruent, you can set them equal to each other. All you would say is that opposite sides are congruent. If it's a parallelogram, then the consecutive angles are supplementary. What are consecutive angles? The ones next to each other. They're called same side interior, or otherwise known as consecutive interior angles. If the opposite angles, these ones are opposite, they are congruent to each other. You can use that. You can also use the fact that the diagonals bisect each other, meaning they go through each other's midpoints and they create two equal pieces. There are four properties that we know about parallelograms. We will use them all to solve problems, sometimes differently, not at the same time. The second things that we're going to do is if we're going to try to determine, is it a parallelogram? Here's how we're going to decide. If both pairs of opposite sides are congruent, then it's a parallelogram. If one angle is supplementary to both consecutive angles, then it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. If the diagonals bisect each other, then it's a parallelogram. If one pair of opposite sides are congruent and parallel, then it's a parallelogram. If you are confused, come back to the notes. Otherwise, let's do some examples, and then you guys will have the rest of the time to do the problems in class today. First example I have chosen for you is number 2. The directions say all the figures are parallelograms. Solve for the variables, then state the property of parallelograms that allows you to solve for the variable. They tell you that DG is 2x plus 2. What I usually do when they say DG is this, I usually will write it in the picture. So I suggest to you, when it says the letters DG is 2x plus 2, that you go find DG, the segment DG, and put 2x plus 2 next to it. They also say that DE is 3x plus 1. I would recommend that you put the 3x plus 1 next to the DE. Side DE is 3x plus 1. DE is 3x plus 1. I do E, same with EF. And the same with GF. So that's my first step. That's my first step. It looks like that. And then I have to make a decision. How am I going to solve this? What property can I use to figure out what x is? And it's the very first one. I can use this property that the opposite sides are congruent. I'm going to write that down as my property. I go down here to number 2. Opposite sides are congruent. That's the property I'm going to be using to figure this out. What does that mean? That means that this opposite side and this opposite side are congruent, and this opposite side and this opposite side are congruent. It doesn't matter which one you pick. You can pick these two, or you can pick these two. Either way, x should be the same in both. If I did 2x plus 2 equals 3x minus 3, that's one way to do it. Or you can do the 3x plus 1 equals the 2x plus 6. All you do from here is subtract 2x and subtract 2x. So you do the same stuff that we've been doing since the very first part of this unit. 3x minus 2x is 1x minus 3. Add 3, add 3. I'm getting that x is equal to 5. I bet you, though, if I did that over on this other one, I bet you we get the same answer. Let's see, 3x minus 2x is x plus 1 equals 6. Subtract 1, x is equal to 5. Either way, you would have gotten x is equal to 5. They don't ask us to do anything else other than to find x. And what do we use? We use that the opposite sides are congruent for number 2. Number 11 and number 9 we're going to do sort of side by side. The directions are the same though. Can you prove the quadrilateral is a parallelogram based on the given information? Those are our directions. And explain. Well, these two arrows mean that they're parallel, and this means it's congruent to that. And I have to decide, is this thing a parallelogram? And then over here I have a parallel, and congruent. So I'm going to go back up to my notes, what I had you write down. If I'm trying to decide if it's a parallelogram, I have to say, well, are both pairs of opposite sides parallel? That's the definition. Or let's see, one pair of opposite sides are congruent and parallel. One pair of opposite sides are congruent and parallel. Let me see about that one. Does this have one pair of parallel sides that are congruent to each other and parallel? This one's yes. One pair of opposite sides are congruent and parallel. It's that last thing that we have. Now the weird part about number 9 is, if I look at this, these are parallel and these are congruent, but I don't know how long this side is and this side is. As a matter of fact, if I were to think about two parallel lines, let me just draw you two parallel lines. Parallel, parallel. I could have something that looks, something like this. Because it doesn't say how long these are. This could be a little bit longer. This could be a little bit shorter. I don't know how long that would be. It could be something called an isosceles trapezoid. So I'm going to say no for number 9. It could be a trapezoid. And a trapezoid is not a parallelogram. The last example that I'm going to do with you guys is number 12. Number 12 says, for what values of x and y must each figure be a parallelogram? And so you're going to have to decide how you're going to attack number 12. You could use that the opposite angles are congruent. Like I said, this equal to that, but then I'd have a y and an x in a problem and another x and a y in a problem. If I can avoid that, I should. So maybe I should just stick to these two sides here and call these consecutive angles. These consecutive angles are, it says it up in our notes, supplementary or adds to 180. Well, if that's the case, then that means that this angle here and this angle here should add up to 180 degrees. We could solve that very easily. 4y plus 2y is 6y equals 180. 6y is 6 times y. The opposite of times is divide by 6. So I'm getting that y is equal to 30 degrees. And you could do the same thing if you wanted to for your x's. But I'm going to do something slightly different. What if I plug the 30 back in right there? 2 times 30. Do I know what this angle is right there? That angle would be 60 degrees. And now can I use the opposite angles? This angle should be congruent to that angle because they're opposite angles. That's going to be a little bit shorter, a little less work, because 2 times 30 is 60. If you wanted to, though, you could do this plus this equals 180. X plus 5x minus 180 should equal 180. And you could do that problem, and you would get the same answer, though, by the way. I'm just going to show you this for good measure. If I divide it by that, x would be 60 that way as well, just so you know. I'm going to stop your notes right there.